topic for today's video is going to be types of reactions. And specifically, the one we're going to focus on today is the precipitation reaction. So first off, three types of reactions that we ultimately want to talk about are first the precipitation reaction, which by definition is a reaction in which we form a solid as a product. This happens in solution. Now, the second kind of reaction, which also happens in aqueous solution, is an acid-base reaction, which we also call a neutralization reaction. We'll get to that one at another time. And then finally, the last kind of reaction that we're going to study is the redox reaction, which involves a transfer of electrons between reactants to form new products. Alright, so I want to focus on the very first type, which is the precipitation reaction. That's going to be the primary focus of this video. Now, when we talk about a precipitation reaction, we have to understand that this involves electrolytes, which are soluble salts or ionic compounds in aqueous solution. Now remember, when we talk about ionic compounds, these are typically going to be a combination of a metal and a nonmetal, or will involve polyatomic ions. The point is, we have two ionic species that of course are held together electrostatically, one being positive in charge, one being negative in charge. So the thing that we have to understand about this when we talk about these types of reactions is what we really mean when we actually have an aqueous solution of an ionic compound. Alright, so one thing we have to understand is that an ionic compound can either be soluble in water or insoluble in water. And we have a set of solubility rules that are in your textbook and which I'll give you that help us to predict that. So the point is, some solids or some ionic compounds are going to be soluble in water, others will remain solids when we put them in water. So let's look at a couple of simple examples of what happens when we dissolve a soluble electrolyte or ionic compound in water. So for example, we know that sodium chloride is soluble in water. If I put some solid sodium chloride in there and stir it up, it's going to dissolve. Now we need to know what's going to happen to that sodium chloride when we do that. So two things happen. The sodium chloride first dissolves, but we also have to understand that when it does that, it's going to dissociate into its component anion and cation. Alright, so when sodium chloride comes apart in water, what we really have is aqueous sodium ion, and we have aqueous chloride ion. So that's the dissociation part. So any soluble salt in water will dissolve and dissociate into its component ions. Sodium chloride being a good example. Another one might be potassium sulfate. Here's an example of an ionic compound or electrolyte that involves a polyatomic ion. Now, when we put the AQ here, this means that it both dissolves and dissociates in water. Alright, so when it comes apart into its component ions, what we're going to make is two ions of potassium 1+ and one ion of sulfate. Okay, and I know that's true because remember, a potassium ion is always 1+ in charge. I have two of them to balance out the 2- charge on the sulfate. So when this thing comes apart, it's going to come apart into three individual particles. Two potassium ions and one sulfate ion. Now I can also have something like barium sulfate, which is actually an insoluble species. It's a salt, but it's not soluble in water. So as a result, if I were to go to the stockroom and get some barium sulfate and throw it into water, it's not going to dissolve. And if it doesn't dissolve, it doesn't dissociate. So what it means is that I have no reaction here if I put barium sulfate into water. Alright, so the next thing we want to do is take a look at some examples of reactions that involve these ionic compounds to form a precipitate or a solid. Alright folks, so if we're dealing with a precipitation reaction, again, what we're trying to do here is to form a solid in aqueous solution. Alright? So, the way this happens is that two soluble salts already in aqueous solution are going to combine to form one or more solid products. Now, how does this happen? Now, this happens by way of what we call a double displacement reaction or mechanism, in which case the ions are going to dissociate and exchange partners to form new products, at least one of which should form a solid. Alright, so an example of this would be aqueous sodium sulfate combining with aqueous barium chloride in solution. Now again, the AQs down here tell me that these particular species are soluble in water. Now, let's just make sure that we understand the charges on the ions here. I'm just going to verify the formulas. So sodium ion is always a 1+. I've got 2 of them for a 2+. That balances out the 2- charge on the sulfate. Do the same thing for the barium here. Barium is always 2+. Chloride is always 1-. I've got 2 chlorides in the formula for 2-. So I got charge balance here. Now what I'm going to do is I'm going to predict my products by letting the ions exchange partners. Okay? So now the sodium will let go of the sulfate and it will grab the other anion, which is the chloride. So the 2 products I would expect to make would be a combination of sodium ion, 1+, chloride ion, 1-. That happens to also be soluble, as you guys know, so I'll put an AQ there. And then what's going to happen is the barium ion is going to lose the chloride and pick up the sulfate. So I'm going to end up with barium 2+, and that will combine with sulfate 2-. And we can again check our formulas to make sure we are properly charged balanced. Now, 1+ on the sodium, 1- on the chloride, so we have a good formula there. We're all balanced out. Same with barium ion and the sulfate ion. I've got a 2+ on the barium, a 2- on the sulfate. And the other thing we need to know about barium sulfate is that it is an insoluble species, as we saw before. Okay, so I'm going to put an S down here to show that that's my solid product. So we've obviously got a reaction here because I took 2 soluble species in water, allowed them to react with each other, and I got an insoluble product. So that's a good example of a precipitation reaction. Now, this reaction, which I've left unbalanced here, is an example of what we call the molecular reaction, because we've left all the species associated as if they were molecules. So let's balance this thing. All right, I've got 2 sodiums on the left. I need 2 sodiums on the right. I've got 1 sulfate on the left, 1 sulfate on the right. We're good there. 1 barium on the left, 1 barium on the right. 2 chlorides on the left. I got 2 chlorides on the right. So we've got a balanced reaction equation here. Now, the next question is, are there alternative ways in which I can write this reaction? And it turns out that there are. So another way I can write this is as what we call an ionic reaction. And in an ionic reaction, what I'm going to do is I'm going to write this reaction out again, but now I'm going to let everything that can dissociate into ions dissociate into ions. So I'm going to show this reaction occurring as individual ions in solution. So anything with an AQ under it, I'm going to break it apart into its component ions, as I just showed you a little bit before. So let's break sodium sulfate into its component ions. So if I do that, I'm going to get per sodium sulfate coming apart 2 sodium ions. So it's going to be a 2Na1+. It's an aqueous solution. I'm going to get 1 sulfate out of that. Also an aqueous solution. Now I'm going to break up the barium chloride. I can do that because it's an aqueous solution. So I'm going to make a barium ion. Keep charges on these things. And I'm also going to make how many? 2 chloride ions. Also an aqueous solution. Alright, so that's everything on the left of the arrow. Now, let's see what we have on the right-hand side of the arrow. I'm going to make 2 molecules of sodium chloride. So when I break this up, that 2 distributes. So I'm going to make 2 sodium ions in solution. Okay, those are in aqueous solution. I'm going to also get 2 chloride ions, we can see from the stoichiometry. And now we get to the solid barium sulfate. Now here we have to remember that when we have a solid, and if we put a solid in water, it's not going to dissolve or dissociate. So because of that, I have to leave it as an associated solid. So I'm going to do that. I'm just going to put the barium sulfate up here and leave it associated as a solid because that's the product that I form. All right? So I like the ionic reaction because it actually, I think, gives a better representation of what's actually happening in this reaction. It lets you actually see how the compounds come apart in aqueous solution so that now those ions can then recombine to form new products namely the barium sulfate. Now there's one other way in which I can write this, which is a little bit more concise. Now, the only real product that I'm getting out of this is going to be the barium sulfate. It's the formation of the solid. In this case, I'm only forming one solid as my product. So as a result, what I can do is generate the net ionic reaction, which basically shows me just the part that matters, which is the formation of the solid, the barium sulfate here. So I'm going to focus on just that one part. So what I do is I look up here in my ionic equation, and I look for things that are exactly the same on both sides of the arrow. And if they're exactly the same, I'm going to cancel them out. Okay? So notice, for example, I have 2 sodium ions on the left. I can cancel that with the 2 sodium ions on the right. Alright? I've got a sulfate on the left, but I can't cancel it over here because now it's part of the barium sulfate, so it's not exactly the same thing. The same argument holds for the barium ion. It's barium ion by itself here. It's tied up as barium sulfate over there. I can't cancel it. However, I have 2 chloride ions existing on the left, 2 chloride ions existing on the right. All right? So those ions that I've actually taken out, we refer to as spectator ions. We call them that because they're really not taking part in any way in the actual reaction. They're just kind of spectating or watching. Okay? So we can eliminate them. They don't actually take part in the formation of the solid. So now for the net ionic reaction equation, I'm just going to write down what's left over that I didn't cross out. So what I have now is barium ion in solution, plus the sulfate ion, also in aqueous solution. And now I'm forming my one solid product, which is my barium sulfate, BaSO4 solid. So that would be my net ionic reaction equation. So it's really distilling down specifically the one important part of this reaction equation that yields the product that we can isolate, which is going to be the solid barium sulfate. All right, so that takes care of this, and we will practice a little bit more with this next time in class. See you later.